The Cold and the Old is a presentation on a select history of the places, projects associated with water and sanitation in Canada's north. The duration of this goes back probably about 100 years and moves forward to the present time. The first place I'd like to discuss is Dawson City. And Dawson City really got its infrastructure start as a function of the Klondike Gold Rush. And really its infrastructure was a function of water and sewer, I call it, after the big rush. It originally started out with a very simple system servicing a small portion of the community. And what is unique about that system is that for almost 80 years it was a wood pipe system, a wood stave pipe system, and it was installed during an 80-year period, and it was replaced over the last, 40 years with more conventional water and sewer systems. And that includes hydrants and insulated HDPE or plastic pipe. And what is, unique about that system is that there are online hydrant systems. So wherever there is a fire hydrant, it'll be within or online with the water system to provide freeze protection. The second place I wanted to talk about is Alert. And Alert is Canada's northernmost, operating facility. It's actually a weather station and a military facility. But it has a mixture of water and sanitation, of water and sewer pipe that has developed probably over the last 50 years as the station was first opened and it is operated. So it has a long water supply line to what is called Dumbbell Lake, and it's an insulated water supply line. You can see it is an orange pipe, and then it has a recirculating pipe. So the large diameter pipe actually draws the water in, and there's a smaller pipe that takes water back to actually provide a recirculating system for the water supply as freeze protection, because as long as you keep the water moving, it'll stay, for the most part, it should stay unfrozen. But you can see that Alert has a mixture of water and sewer pipes, and in some cases looks fairly disorganized. It also has a sewage disposal system that actually goes down the embankment into an embayed area, and this started out just as a direct discharge of the sewage, but in fact they've added a wetland system so they get some treatment before it is discharged into the ocean. Yellowknife is what I call water and sewer on the rocks. Yellowknife is situated geologically on the Canadian Shield, so every bit of the infrastructure serving that community is associated with rock excavation and dealing with the rock and the mining. What is interesting, or in one sense, about Yellowknife is that the gold mining over the years has actually contaminated a lot of the lakes around the area with arsenic, and that has played a large part in terms of how the community has approached its water supply. They've made sure that their water supply system, or the water source, is actually 8 kilometers away from the community, so that they're drawing water that is outside the potential contamination of the mining activity. But you can see in the one slide where they've got the water sewer system being installed is that it's a combination of water. The water and sewer are insulated pipelines which has service connections going to each individual house, and within that each individual house there's the water as a supply line and a return line. So once again you have this recirculating pipe system, or a recirculating water system that keeps the water in motion and makes sure that the water stays freeze protected. The part of the system as well is the use of fire hydrants, and these fire hydrants are actually installed in concrete vaults or concrete manholes so that they provide a stable platform, but also someplace that has some heat protection. One of the most interesting places in the far north in terms of the Cold and the Old is the town of Inuvik up above the Arctic Circle. There is a historical fur trading community called Aklavik, which is about 50 kilometers away, and this community was subject to flooding each spring as a result of the flows on the Mackenzie River Delta. The community, it was decided by the Government of Canada to relocate the community, and the site of Inuvik was actually selected over the course of the 50s and was completed with construction in the early 1960s. So what was decided at that time in terms of the best technology was actually putting the entire water and sewer system above ground. And the reason for this was the ground in and around Inuvik has the permafrost is actually very ice rich. So if you disturb the ground to any extent, the ice starts melting and actually has some fairly significant ground movements. So it was decided to put the entire water and sewer system above ground, and within that they had the water line, the sewer line, but also the heating system. And similar to, I guess, a European approach, they had a district heating system that served the community for almost 50 years. This system was a high pressure system, so that eventually it became, I guess you can say, obsolete and was actually decommissioned over the last probably 20 years. But still, the replacement of the water and sewer system has been kept elevated. So you've got now, just instead of the 4 pipes with the district heating system, you've got a series of 2 pipes. So you've got a water supply line, which is recirculated, and you've got a sewer line. But both of these systems are insulated and, as I said, above ground. Callowwood is another interesting place. It had its origins on the south end of Baffin Island as a military base during the Second World War. So it was an airfield that was actually used for the resupply of, or the supply of, aircraft to Europe. So it was one of a series of airfields that started down in southern Canada and allowed aircraft to hop, skip, and jump from Canada to Greenland to Iceland and then to the northern United Kingdom. So within Callowwood, it started out as some very basic infrastructure and as a military base. But from the pictures you can see on the slide is that it has evolved into a buried water and sewer system using insulated plastic pipe that is generally placed in a shallow position, generally less than 2 meters deep. So it is within, or generally within the, or below the active layer. So it is protected in the permanent ice layer, but at the same time it's subject to not subject to the freeze thaw that occurs over the course of the yearly thaw from the warm summer months up there. But with the series of pictures, so you can see these brown, I guess you can say, tin cans that are part of the system as well. These are what are called access vaults, and are the manholes that are used to connect between the various sections of the water and sewer system. But an interesting point about Callowwood is that during the late 50s is that there was a plan to build this modern city of towers and a centralized system. And this grand scheme, which would never have worked, but it was an interesting concept that the government at the time came up with to try and create this modern Arctic community. Another place of interest is Whitehorse, and I call Whitehorse water and sewer at the end of the railway. Whitehorse got its sort of start during the Klondike, or at the end of the Klondike Gold Rush, with the construction of the White Pass and Yukon Railway. So it became the terminus of the White Pass and Yukon Railway, and from there it was a point of navigation that could allow steamships to move downstream to Dawson. So it has a unique, I guess you'd say, a unique in one respect of an Arctic features that it doesn't have permafrost per se. It has sporadic permafrost, so they're in a position where they can in fact bury their water and sewer system, and for the most part they try and bury it below the penetration of frost, which is about 3 meters. So all of their water and sewer systems are generally buried below 3 meters, and the only places they really require freeze protection is areas that are exposed to and don't have any snow cover. So in some cases the only places you'll have insulated pipe is where there's road crossings or where the actual sewer and water system is within the road profile. A series of projects that I want to go through have different features and some different histories. The first one I wanted to look at was Resolute. Resolute is the community in the very far north that was originally designed to accommodate about 2,500 people. So it was planned and executed with infrastructure that would support this population. But as it turned out, over the last 40 years, in fact, it's only developed a population of 250. So this infrastructure is now being replaced, but at a much smaller scale. And there has been a lot of study done on the community of whether to go with a piped system or whether to do with the level of service that a lot of northern communities in Canada with a truck system. So that has had a lot of debate, and the community, in fact, selected to go with a pipe system. But this is now a system that is going to be, by the time they finish the water treatment, the sewage treatment, and the replacement of the water and sewer pipeline, is probably going to cost upward of $40 million. I think that works out to be about $200,000 per person, which is a fairly expensive system. The Dawson City wastewater treatment system has a long history because of its proximity on the Yukon River and being an international salmon bearing stream. Is that when the infrastructure was improved back in the late 70s and early 80s, it was demanded that they actually go to a conventional system. As a first step, they went to a primary system, a screening system, that takes out the coarser materials, but it was expected that they would go to a secondary system. And as that project sort of unfolded over the last probably 20 years, is that they were originally going to go to an SBR system, but unfortunately the operation and maintenance costs were very high, and the government of the Yukon decided to do a design build, and it was selected or the proponent that won the contract to build the system selected a system that's called a deep shaft. And as that project has actually turned out, it is operational, but the cost of it has been probably close to $30 million. And what is really significant is that the operation and maintenance costs are over $1 million per year. And this has really instigated the government of Yukon to possibly look at replacement systems for that. The Penguin Reservoir was a unique project because it was really the first system or facility in the Canadian North that used a lined pond system for water storage. And line systems have a lot of difficulties in permafrost regions because the dynamic system of the soils. Permafrost or ice in soil has a tendency just to move around a lot, and even with flexible liners that become less flexible in the cold, there are issues. But the Penguin Reservoir, which was constructed now probably almost 35 years ago, has performed well and is, I think, a good example of how a line system can perform. Going back again to Inuvik, is that in terms of a project, the Inuvik Utilidor system has been now replaced, in the process of being replaced over the last 20 years. And they've decided to maintain the above ground system with, again, going with a dual system or two pipe system, one for water, one for sewer, that is being put on pile systems, and associated with that is the cost. And the cost is extremely high, and it's probably worth somewhere around $6,000 per meter for the replacement of the pile system. The Yellowknife Water Treatment Facility was developed as a response to what was sediment in the water supply, but also, as I discussed before, is that with the arsenic potential of the area around, or the waters around Yellowknife, there was a serious consideration of moving from what was an 8-kilometer supply point from the community to a closer supply point, but recognizing that there might be some arsenic related issues. So this water system has the provision for arsenic treatment. The community has decided that they want to maintain the original supply system from the Yellowknife River, which is 8 kilometers away, but they have a situation where the water supply line now is at the end of its service life. So they're working on a project to actually replace that 8-kilometer water supply line. The Whitehorse Lagoon is another interesting system that had its origins going back now probably 30 years ago, where Whitehorse was using a primary lagoon system, but they came under quite a degree of scrutiny because they were discharging into the Yukon River, which is upstream from Dawson and really under the same international, I guess, influence in terms of being a salmonoid stream. So they were originally planning to go potentially with a mechanical system, and recognizing that would have been an extraordinary cost, they decided to do with a primary, secondary, and a storage lagoon system. And by way of some convenient topography, I'd call it, there was a large flat area within a close proximity of the community, they were able to construct this lagoon system. And what was really interesting about this is that in the original operation of the system, they did not have to go to a direct discharge to the seasonal discharge to the Yukon River, but we were able to use what is called a pothole lake and basically discharge the effluent into the groundwater system rather than the surface water system. And this has put them in a position that the regulators were essentially leaving them alone in terms of the surface water requirements. With time and over the last 10 years, that groundwater discharge system has actually deteriorated, so they're now discharging to the surface. But that system overall has provided an excellent effluent discharge over the last, I guess, 25 years, and certainly sets the bar for how lagoons may operate in the far north. The Iqaluit wastewater system has a unique history because they were discharging raw sewage into a large embayed area, which was not really appropriate because it did not get a lot of natural dispersion. So they went with a design-build system back in the late 90s, and unfortunately this system was not commissioned, or was never commissioned, for a whole variety of reasons. But they're now in a position where they're upgrading to a secondary system now 20 years later that involves a sulcinous filter as the primary treatment, and they are now putting in an MBBR system of secondary treatment that will be, I think, constructed or finished in about 2021. That's the end of my presentation, and if you have any questions, send me a note online. Thank you.